In the last video, we saw the algebraic rules for finite sums. In this video, we have two problems where we're asked to use those rules to evaluate two sums. Now in this first example, if I was just asked to evaluate the sum, I could just evaluate the kth term formula for k equals 1, 2, and 3 and add those together. But I was asked to use the algebra rules. So what I'm going to do first is split this up using the sum and difference rule. So I'll have three sums instead of one. All right, and this last sum's easy to evaluate whether I think about actually going from 1 to 3 or if I think about the constant rule. Right, this is a constant added to itself 3 times 1 is 1. Excuse me, 3 times 1 is 3, and it's really just 1 added to itself 3 times. I get 3. All right, for this first sum, I can factor a 3 out front. The second sum I don't have anything to do with, so I'll just write it down here in this step. And now, with the two easier sums I have left, I'll just evaluate them. So plug in k equals 1, k equals 2, and k equals 3. And then 1 plus 2 plus 3, because I'm just adding together the first 3 whole numbers, and then add 3. Well, and when I evaluate all of that, I actually get 42 minus 6 plus 3 is 39. And there I've used my algebra rules to evaluate that sum. Moving on to my second example, I actually have to use my constant rule because I don't know what n is. I know n's a number, and I know that I'm adding up from 1 until I get to whatever that value is. And so if I wanted to start with a concrete example that was like this, I could imagine maybe that n was 5. And then I'd be adding 2/5 to itself 5 times, and I could use that constant rule and I'd get 2. And that's when I realized that no matter what the stopping number is, it's just a number. It's a constant, right? I stop at n, so even though there's an n there, it's a constant in terms of the sum. So I had to have 2 over n times n, and I just get 2. And you can actually see this in my little thought bubble too, because no matter what you replace this number with, you have to replace all of the places that 5 showed up, and you'll always get 2.